Hello everybody and welcome to this process tutorial where I will show you how to create a well-designed water bucket in Shapr3D. In this video I will focus on a smart process using only few sketches combined with effective solid modeling techniques to create surfaces with a thickness, as you can see here. Further, the reference file includes all the individual modeling steps, so you can study how I approached solving this design problem. Before we continue, we want to make sure that units is set to millimeter and all our snapping and guides are turned on. For reference purpose, to study and analyze and learn from this model, I included the final design inside the Shapr model. When we take a look at the surfaces, we can see that there are various design problems or surfacing challenges. For example, these two surfaces are offset, plus there's a transitional surface. We have a spout that is very nicely joined, and we have a rim with a thickness that runs all across, and to make matters even more complicated, the bottom face is at an angle. Now all this looks rather complicated. Is however very easy when you, instead of seeing the complexity of all these problems, break it down into smaller problems and then via smart sketching and modeling solve it. So with that said, let's go to bottom view. We will make a sketch, ellipse from the center, a sketch that is 160 by 110. There we are. This we will call base. And I will hide this. To match the design, this has to be extruded up 250 millimeters, and we will add a draft of -5 degrees. So you see, this shape could also be created via two sketches and a loft. This, however, is much faster. One sketch, one extrude with a draft. We will call this outside. And I will hide this. Take a look at this view. And we see that now we have this surface that is offset or smaller, so it sits on the inside. To create this, we will continue making a sketch like this. This should be 101. We make another line. These two lines will be parallel. Then we can zoom in more. The more we zoom in, at one point you see the grid will refine nicely. There, this position is good. Lock it. At this point we can move up. These two lines have roughly a distance of 28 millimeters. Very good. We will call this also trim. And I can select these two profiles and cut. Then I select this and cut down. Now it works. 2 steps. However, I would like to make this even easier. So before I continue, I will select the whole sketch and move it down 200 millimeters. Because now I could select and simply cut the whole piece out. Very good. This I will hide. Let's make another body. 190 -5. Very good. And then I select this, go up, and here we select intersect. This will be the inside. And when we take a look at this, you see the sides are kind of like the same. So the surface now we have to offset. I will use 5 millimeters. To create the transition between this face and this face, we will use the loft command. There we are. And then selecting all three objects, select union to join them together. Let's call this bucket. We will go back for the next step soon to the base sketch. Before we could do this, let's add a 15 millimeter radius there. And here we can add a 25 millimeter fillet, not radius, sorry. Let's go to base, turn bucket off, select this sketch with a finger double tap, and we will add an ellipse again. This will be 130, and this 110 minus 30 is 80. So we have from the bigger to the smaller ellipse an offset of 30. When I have very basic geometry, I like always to redraw them by hand instead of using the offset command, because very often offset commands will create a more detailed offset path. So in this case, this was not very complicated to do. We will show the bucket one more time. Then we will select this new fill, extrude it 20 millimeters in, and it cuts. And then we add a positive draft of 45 degrees. Very nice. And we would like to rotate this face. So we can select it, then go to move and rotate. I made sure where I want to have the spout later, and this I rotate by 3 degrees. The spout I have on the left side, so my hand to hold will be here, which means this has to be 3 degrees. So I have a bigger area here. I don't need a bigger area there. Very good. Now then I can go ahead and round these edges 15 millimeters. Very good. This looks nice. The next step now would be to create the spout. I will select the top surface with my finger double tap. That lines up the grid. For reference purpose, I can turn on the target object, go to spline, CV, and start drawing. And I press and release, go back to line and create myself a quick profile. This all looks really good. Just a little tip, you see here the midpoint is lined up to the x-axis, which means then I can use the grid and simply count the positions and make sure all these points along this line are symmetrical. Very good. This I will hide. This whole object I will extrude down 90 millimeters, shrink it via the draft. And here comes now the interesting trick. We will select the face and this edge, turn on bucket, and then we just move it in there. And then there we have this beautiful transition. So you see also here, the spout we just create via one sketch and one extrusion command, and then we move the target edge. So we don't need two sketches for loft. The two bodies we will join. So they are one. Very good. then this we will rename spout, and height, we don't need it for the moment. There we are. So you see, so far this was actually a fairly simple process. We give this a really nice and generous fillet, 50 millimeters. This is very good. And to now create the rim, we'll go to the back, and we'll go to here and draw myself a line. 16 millimeters. This goes down 10, 2 millimeters. I use the grid here, or I can also give specific dimensions to make sure everything is the same, the way it should be. Could also say these two lines should be the same, so I use simply equal. And because I'm using the grid and the first body was extruded up with 250 millimeters, terminating at the grid, I don't need to project any line from this 3D model into the sketch. I simply use the grid and line up everything. So I will move this to there. We will make this 15. Now I bring this over, overlap this, so I'm overbuilding, and this I move to here, draw a connection, and then this point sufficiently move in there. This is at a deep angle because this is a really deep line or angle there. You see that too. So I need to match this. Then I can zoom out, go to 3D view, select this profile, select all these edges, sweep, make a cut section, verify perfect, no gaps or anything, and the rim and this body I can join. And then this. Let's call this rim. Very nice. Now the rim has a thickness of 2 millimeters, which means if we now shell this object, by selecting the top face, go to shell, we can only select it, or I can only select 2 millimeters or bigger. We can't go smaller because then the shelling would go into the lip. There we are. Very good. Now we have here some very sharp edges, which is not good. This edge and this we will fillet with 1 millimeter. These two have a thickness or an offset of 2 millimeters, which means then this is 2 millimeters plus 1 millimeter, means 3. So the outer edges have to be 3 millimeters. So that we get a beautiful offset. Okay, very good. So this is then the whole process, how we can build the bucket. As you can see, with a simplistic approach, only a few sketches, and then few modeling tools. Then in this video, the next step then would be how we can model the handle. I will hide this for the moment. Take a look at this. And there we can see we have these two sockets with a hole in between and the handle on top. And the handle also has a space and an axis. Also, this is quite simple to design. Okay. So we will start from the center again. I will show my design here, go to there, zoom in a little bit, make a sketch, circle, and here this will be 3 millimeters. As you can see, this lines up to there. Very good. I will use the spline curve one more time and create myself a nice arc that goes around. I will use here this to cap the bottom. Very good. So as you see, I clean everything up a little bit with the grid. So everything is symmetrical. This is around 5. So this is 5, which means then in these 2 points, when I select them, move them up there. So this looks better. Very good. To make things a little bit more thicker, select those 2 and then those 2, move them along the grid, 2 units each. Nice. And this I will move down. Very good. And maybe those 1 time up. There. This was actually now added to the rim sketch. As you can see, this is joined. You can keep it this way, or if you would prefer to separate it, we can select this off our sketch with the move command, then bring it over 135. Okay, very good. There we are. We can select this, extrude it out by 5 millimeters. Double select it. Here's a nice little trick. You see the grid is vertical, and then I will go to mirror, select or simply tap on the grid, and that mirrors the whole piece over to the other side. Very good. Now this we will call socket. And we could call the socket, but since we will join this later to the bucket, I'm not bothering with giving those a name. Everything else we can hide for the moment. We don't need. Also, this copy I will hide. And I would like now to create the sketch for the handle centered on the cylinder. When you select a cylinder, we can add an axis that runs through it. Then we can go to Add, Construction Plane, through Edge at an angle, select this guideline, next, and this should be 90. That's horizontal. Very good. Let's hide this for the moment, and also socket. Then we want to see our bucket. Select this construction plane, and then with our finger double tap, and now we are sketching right on this construction plane. We will do an ellipse again. It will help knowing also where our socket is. So this looks pretty good. So 135 by 190. So this is too far. 185. This looks better. I can see that all the elliptical shapes of my 3D model line up also with the sketch. Then I will make one more ellipse, 195. So it's on it. Very good. And Zoom this in. 145. Okay, yes, very good. Here's a little trick, because I want to work smart, not hard. I will create a line here, but be careful. You see, I just drew the line, but it put it onto the ground plane. So I will select this sketch one more time, put my finger, double tap. Now I draw this line into the sketch. Same here. Very good. I noticed that actually there it drew it over this axis, so I will hide it. You see I made the mistake one more time. So it's an easy mistake by just going to top view. You just want to select the sketch or any plane, then double tap on it. Then you're drawing in it. Now we can show these elements. Let's zoom in. We give this a distance here, go over to there. Snap this to the grid. Snap this to the grid. Very nice. So you see it's a millimeter distance. Very good. So the reason why I did everything that way is, well, why should I make myself work hard when I only need to model this one side? So I extrude this down 5 millimeters. Then I will adjust the height to 10 millimeters. And we would like to add here 10 millimeters to it. Or actually 5. And then these two edges we round also by 5, turning this into a perfect cap that's round. There. Let's take a look at our elements here. There you see, this looks really, really good. Here's our socket. So from there we do an extrusion, but instead of cutting into it, we do a union, we join it. This we will call handle. This is slightly in our way, so we can hide it now. The socket now we can hide. We can show our socket objects. What's the distance? This is 5 millimeters, which means if I would like to perfect this model a little bit, this I would like to extrude. By another 5 millimeters. Okay, so, and it's joined. Very good. So you see that this is now inside it. Oh, actually it's not. Oh yeah, that makes sense. Sorry, my fault. This was already modeled flush added. So this we only need now to extrude by, let's say, 2 millimeters, and I will do a new body. The reason why I did a new body is now I can select this, set this to 4 millimeters, so it's a little bit bigger, and then this and this I will join. Very good. And then the whole object I will mirror over to there. Select both, join. Very nice. And there we are. That's our handle. And now we can round all the edges nicely. 2 millimeters. Also this 2 millimeters. Round this by 2. Round this by 1. And then we do the same here. Very good. So this rounding I did right now, I could have done also on half of the object and then mirrored everything over. These elements here are not, technically speaking, from an engineering standpoint, perfectly correct. They need to be a little bit carved out, but this would be beyond the scope of this video, so understand that this is just a simplification. Let's call this handle. And our last step to do is we need to join those to our bucket. There, and there, and this, and join. Let's see if this works. It did. Very good. The sockets were sitting right on the bucket. So in case, just for the sake of explaining, in case it doesn't work, when this is not intersecting, we can also extend this by 1 millimeter. Let's say here too. And then the surfaces truly much better intersect. There you can see this now, how they would intersect. That's in general, the term is called overmodeling, and this will help then the software understanding where the volumes are and how to calculate it together. Last step here to make this a tick more refined. Just 1 millimeter, very good. Let's take a look where everything finished. And there's actually now our finished bucket. With all the surfacing details we wanted to have, more ergonomic space for our fingers down there to hold, a nicer look with offset surfaces at the sides, a clean and well-working spout, a lip or a rim that stabilizes the bucket, and then here we have a handle that follows exactly the surface. For simulation or prototyping purpose, if you would like to rotate the handle, we can select it. So double tap, and then we move this to the cylinder, which then acts like an axis. And we could just rotate it and see how this would work. Very good. And that's it.